So today we are looking at lesson 20. Lesson 20 is still pretty much review. A little bit more about logs. We did logs, was that Thursday, Friday? Thursday, yeah. Friday was definition of derivative, wasn't it? So we did logs a couple of days ago, some point last week. But one of the things we did not talk about is change of base formula. And change of base formula, the benefit is when it's a log that you can't, we could graph a log base 10. We can graph a log base e, that's natural log. But other than that, we can't really do a whole lot with them. So our change of base formula. If you have log base b of x, it can be rewritten of one of two ways. You can either rewrite it with natural logs. So it's the natural log of x divided by the natural log of b. And notice these logs are both natural logs, so they're both e. Or you could rewrite it as a log where you pick, it would probably be base 10. So it can be whatever base you want, but log base p of x divided by log base p of b. So it's just, if you're asked to rewrite something using common logs or rewrite it using natural logs, there's just miscellaneous uses for it, really. Okay? So, example 1. Ask us to rewrite log base 4 of x using common logs. So common logs being log base 10. So how can we write that using base 10 logs? What does our change of base formula say? Yep. Log of x divided by log of 4. Now, officially, when we say log of x divided by log of 4, Wade didn't say it, and that's okay, but what base is really in there? It's log base 10, right? I wrote it in there just, to prove the point, but really the easier way is log base x divided by log base 4. Okay? Remember, anytime you use log, and don't state a base, it's assumed 10. That is our common log. Example 2 says to estimate log base 4 of 67 by using a calculator.
So on the first example, it doesn't want the number answer, it just wants it set up so that you could just put equals on the calculator.
Yeah. And on number, the first example, there's an x in there. So we couldn't get just a number example. Okay. Now this next one, it says estimate. So what do they want in the end? A number example. What do you know about log base 4 of 67?
Log of 67 and log of 4.
Okay. Log of 67 divided by log of 4. It says estimate, so we use the calculator here. Log of 67, parentheses, divided by log of 4, parentheses. Did you guys get something?
3.2.
Yep. Approximately 3.0330. Now, officially, I think Wade said base 10, so I used log base 10, right? What's the other option we could have technically done here? Yeah, if you would have done natural log of 67 divided by natural log of 4, there's just kind of your proof. Notice you get the same answer, right? So it doesn't matter which one you pick, just pick one. Example 3. Use a calculator to approximate 4 log base 15 of 6 plus 5 log base 4 of 7. What do we do?
4 log 6 over log 15 plus 5 log 7.
Okay, so the 4 is a coefficient, right? So keep it out front. Inside, it's log of 6 divided by log of 15. Plus 5 is a coefficient. Inside, it's log of 7 divided by log of 4. It's a lot to punch in on the calculator, but it's doable, right? Oh, sorry. There you go. Right, but
Oh, really?
There is, but not all calculators are going to have that. Not even all graphing calculators are going to have that. So that's why I don't, that's why I am teaching how the change of base formula works. Yes, these calculators do have something where you can pick your own base to put in there, but this is a necessary skill. So I'm going to do 4 times parentheses, log of 6, over log of 15, plus 5 times, I'm going to do a fraction again, log of 7 divided by log of 4. Does your answer match mine?
Yeah.
Okay. 9.6649, but the 5 rounds it up, so 50. 9.6650 approximately. Okay. And out of habit, we used all these as logs, but do remember, you can use log base 10 to do this, or natural log. I know it's in the shortcut. Is it in the Is it in one of the menus also somewhere?
It's in the F2.
Okay, because those in the math menu, yeah. If you go number 5, that's the one where you can enter your own base. So for instance, here we could have done, 4 times log base 15 of 6 plus 5 times, double whoops. Okay. You guys get the idea, right? I'm hitting, oh my gosh, I'm struggling today. There we go. I mean, it should be the same thing. Yes, that was going to be my point. That you get the same thing both ways there. Okay. So it's a helpful thing to know both ways. I mean, calculator shortcut is helpful. However, it's also helpful to know how to do it without the calculator shortcut. Questions there? Okay. If log base b of 47 equals 17, what is b? So what do we need to do to set this up to begin with? What's the phrase I would use? Left, right, middle. Okay, take this out of log form and put it in exponent form. So exponent form, this is going to read b to the 17th equals 47. And because we're just such math whizzes, we know exactly what raised to the 17th equals 47, right? Okay. So what do we do here? We take the 17th root. So, b is approximately, you guys remember how to do a 17th root on your calculator?
No.
Is there one in the shortcut menu? Yes. Number 6 in the Alpha F2 menu is an X root, so you get to pick what root you want. It's also up in the math menu. Okay. So I can do the 17th root of 47. Did you get my answer? Approximately 1.2542. Yes. If you use the math menu, it's number 5 in the math menu. So, okay, we okay with that stuff? I mean, again, it's review stuff. Let's look at 20B. Graphing origin-centered conics on a graphing calculator.
Ooh, conic sections.
Do you remember your conic sections?
Yep.
Now, the name rings a bell, and I think that if you told us what it would definitely spark or trigger bad memories.
What kind of conic sections did we learn about last year in pre-cal? Ellipse?
Oh, yeah, I do remember these.
Oh, that was
Okay.
like over, I think it was, I don't know.
Yeah, there was a lot of charts to this one.
There
Oh,
was.
no,
Wasn't there like an online assignment we had to do for that too? I thought we had to like get the graph. So I didn't do it, I remember.
One of the e-learning, we had an e-learning day, fall, where your directions were to
Yeah.
research conic sections. I just, and I asked, there was a couple of questions I asked. But so we didn't really focus on circles, but circles is technically a conic section. Parabolas is the first one. Then we did ellipses, and then we did hyperbolas. Okay, so now the key is, if you have something like x squared plus y squared equals 4, remember there's no plus or minus on either the x or the y, so this is centered at the origin, as the heading indicates here. In order to graph this on the calculator, what has to happen? You have to have a y equals, right? Now, I would like on this particular one, since it's just x squared plus y squared equals 4, I would like you to kind of know that that is going to be a circle. Okay? I don't know if you guys actually do or not, but when it's just x squared plus y squared equals some number, it's a circle at 0, 0, and then the radius is the square root. Now, so if we solve this for y, so what are you guys doing? We solve this for y. Y squared equals 4 minus x squared. And then we will take the square root. What has to happen when you take the square root? Okay. Remember, it's plus or minus the square root of 4 minus x squared. Let me say it before anyone does it. Please remember, you cannot take the square root of 4 minus x squared. Okay, these are two terms being added or subtracted. You can't take the square root of 4, the square root of x squared, and say, there we go.
They're married, they can't.
Okay?
That's how I
Yeah.
Like the Q and the U.
So what has to happen when I go to graph this on my calculator?
You have to do the negative in front and the one without.
Yeah. One of yours is just the positive. So square root of 4 minus x squared, so that could be y1. Y2 could be the negative of square root of 4 minus x squared. Okay. Practice. I want to show you a trick on the calculator. I'm trying to remember if this is something I show in pre-cal or not. I don't necessarily think it is.
Is that a spider on your wall or just like a You see it?
I'd probably just hit the 5.
The one to the right?
Yeah.
Yeah.
The screw?
Yeah, I think it's a screw because there's two on the left of it. I don't know if you can see what the T
We had this conversation.
Sorry, I get nervous. Spiders make me nervous.
So it's not just me having a feeling of deja vu that this happened in another class?
It did. I think it happened.
It's more of an oval,
Okay.
not a circle.
Okay, we'll take care of that in a moment too. Okay, guys, square root of 4 minus x squared. And then what's the other thing you have to do? The negative. So one option is to what? Take the effort and retype square root of 4 minus x squared. Yes? Have I taught you guys the other option? I don't think I have. So what is the relationship between y1 and the y2 that I probably shouldn't have deleted it yet? They are the same thing except... Yeah, these are the same thing except one has a negative in front of it, yes? So instead of typing that out, not that that one was horribly hard to type out, but some of them are easier than others. An option is you can do negative, and it's a negative of where is that other equation typed? It's typed into y1. Now, in the alpha F4 or F5, alpha F4, I guessed right. If you do alpha F4 shortcut menu, notice what's there. Y1, Y2, Y3, Y, all the Ys. So you can pick Y1, and so now this says Y2 is equal to the negative or opposite of Y1. And that would work too. Now, Jackson already graphed this. He complained that it doesn't look much like a circle. It looks more like an oval. Now, keep in mind, that's on a standard Zoom screen, yes? Is my screen perfectly square? No, my screen is more of a rectangle, right? And so even though we go out left 10, out right 10, up and down 10, notice my up and down 10s are more squished together. Okay, not zoom fit. You have an option called z-square. Try number 5. Because what number 5 will do is z-square will zoom square it so that, notice, as you look at those marks now, do my marks look more equally spaced? It doesn't look like my horizontal marks are spaced more than my vertical marks. And so that's z-square. I forget, your left and right still go to 10. Excuse me, your up and down still go to 10, but your left and right go to negative and positive 16. And so that's what...
What decided that exact number? Because that was like a 16.1.
has to probably do with the size of the screen.
Okay.
Does that make sense? You know, like the ratio.
It's a random number. I didn't know where it
And it's not random. It probably specifically has to do with the exact size of the screen. So, now, okay, so Riley's commenting that it doesn't look like they connect. And this is where it's graph or failure. Okay, anytime we do something like this, where you think you're graphing two halves, take the general look. Does it look like it was supposed to be a circle? It does. So assume that the calculator, for whatever reason, does not take that all the way up to the axes or the connecting point. You have to know that they connect there. Okay?
It's kind of satisfying how it's like.
Okay. And it's the perfect circle, centered at 0, 0 with what? Radius of 2. So here's my little sketch. Whoops. One of the things I used was y2 equals negative y1, if you want to make note that we did that. And another thing I did is I used z square to make it look more circle-y. Is that a word? Okay. That would be a better professional word. Well, you know, I couldn't come up with the official word of whatever it should be using, so you got circle-y. But I agree. More circular would be a better word. You don't always... Hey, here's the point. Did you know what I meant? Right? You knew what I meant. That's what matters. So. I agree. A more professional word would be more circular. The professional words just don't always come right to mind at times. Okay.
Especially when you stub your toe.
Random.
Yeah.
Well, the most professional words don't come out when you stub your toe. I fell. I tripped over my foot on Friday night.
Okay. One more, guys. If we're going to use the graphing calculator to do this, what do we need to do? Okay, we want it to be y equals. How are we going to get it to be y equals? Okay, we want those fractions gone.
Out of here.
4 and 9 have a common denominator of 36. So we're going to multiply everybody by 36. When you multiply x squared over 4 by 36 over 1, 4 and 36 cross cancel, leaving a factor of 9. So 9x squared plus, cross cancel 9 and 36, a factor of 4. 4y squared equals, nope. Oh, yep, sorry.
Jack's like,
Very confused.
I had different math going on in my head.
I don't think Jack.
For whatever reason, I was dividing by 36 in my head, and it just... Okay, continue. Now we need to... It's Monday. That's my excuse. Thank you. Let's minus 9x squared. So 4y squared equals 36 minus 9x squared. Then we're going to divide by 4. 36 divided by 4 is 9 minus 9x squared divided by 4, 9/4 x squared. What's our last step? Yeah. Y equals plus or minus the square root of 9 minus 9/4 x squared. Okay. As we get ready to graph this, my x squared and y squared are added again, yes? However, this time there's different denominators. So the circle was added, but the x squared and y squared were identical, and it equaled the radius squared. Here, it's still added. Do you remember what shape this is? The ellipse is when x squared and y squared are added. The hyperbola is when they are subtracted. Okay, so both x squared and y squared have the same sign. Remember again, this is a better example. We're doing y1 equals negative of y2. Might be more friendly, right?
What'd you say? Oh, I guess it's
Now, so square root 9 minus fraction 9/4 x squared. Now, the advantage is I still had negative y1 in there from my last graph, so I don't even have to do anything. If I do a zoom 6, I'm back to my awkward graph. Now, ironically, okay, it looks like a circle. It's not supposed to be a circle, though. It's supposed to be an oval, an ellipse. Okay?
Was that my subject? Love letters?
For me.
It's $1 million.
It's a love letter.
It's for sure for me.
Love letter would be better than paperwork. It's called confidential paperwork, I think. Okay, now my point is, guys, okay, what's happening? Do your counting. Do these go up and down the same distance they go left and right? No, because it goes up and down 3, left or right 2. If you want a more accurate picture, do that zoom square again, and this would give you a more accurate picture of this an ellipse that is taller than it is wider.
No, it really does.
Blue and red.
Now, remember, if you remember anything, it's x squared. The x squared, because this equals 1, right? The x squared is over 4. This means it goes left 2 and right 2. The y squared is over 9. Square root of 9 is 3. This means it goes up and down 3 on the y-axis. Honestly, that one would have been easier to graph by hand than by solving it for y. But we go with what we're asked to do there.
So what does this confidential information say?
Something confidential.
We'll keep it confidential.